welcome. We're going to shift over from color to camera tracking. One has an effect on the other effect on the other. So, my name is Jim Godoldik. I am one of the co-chairs of SMPTE RIS, and between our subgroups, way back when we started RIS, wow, feels like a decade ago, but only just over 3 years ago, we looked at some really pressing issues and gaps in both technical and in education that the consortium of all of us involved in RIS, both from individual contributors to vendors and companies, wanted to make these things not only easier for ourselves, but easier for the industry and the community at large. One of those subgroups was our tracking subgroup. So within RIS, right now we have three main charges. We have color, we have camera tracking, and we have camera and lens. Within what we've been working on for a while under the tracking subgroup, which has been spearheaded by James over here, has been OpenTrackIO, which is a free and open source protocol that just went live this morning in V090, not V1, not version 1. But this has been a long-standing problem in camera tracking workflows that we have found gaps in, and there's a lot of different implementations of this in terms of having to interop between different workflows and different vendors. But that's what we're going to be talking about today, is the release of OpenTrackIO, how it came to be, what we're trying to solve with it. And before we actually dive into it, I will let my fellow panelists introduce themselves. So why don't we start with James down on the end?
Sure thing. Hello, everyone. I'm James Uren. I'm the technical director at MOSIS. We're most famous probably for inventing inside-out optical camera tracking. Since we created that a number of years ago, our product's called Star Tracker. It's for very accurately positioning the camera in a virtual production studio or stage. Since then, we've kind of built out a whole bunch of solutions around that, and we get involved. And I personally get involved on set. I'm a virtual production supervisor as well. And I've, as Jim said, I suppose I've probably been the pushing force to try and get OpenTrackIO to the state it is today, and we're very pleased to be able to announce the launch of it today in version 0.9. We weren't quite ready to commit to that big 1.0. So yeah, that's me. I'm an engineer and a virtual production supervisor, and I love interoperability in virtual production.
Thank you, James. I'm Steve Roselbluth. I'm the president of Concept Overdrive, and my company has been involved historically in the creation of things like virtual cameras, simulcam. We do a lot of motion control and streaming of real-world motion into the virtual world and virtual motion into the real world. I guess first and foremost, I'm an embedded programmer, so I've spent much of my life wrestling with protocols, streaming protocols, and I guess I would say going even back to the 90s, I would look around, practical motion picture sets, and I would see data everywhere, and it was falling on the floor. Nobody was capturing it. Now things have changed recently, but now we have the Wild West of so many different streaming protocols and formats, and it just makes sense that interoperability should be key. So we'll talk about that soon. Ramiro.
Yeah. Thank you. Ramiro Montes De Oca. I'm a virtual production manager for KinoFlow. I'm also a broadcast engineer, and as a matter of fact, also embedded programmer. And I want to take this to 702110-41 as the last panel. We talk about that too. And yeah, I'm a metadata freak too.
Yeah. Hey guys, my name is Marcus. I'm the CTO of a company called Original Syndicate. We're a design, development, and integration company. And we often find ourselves in a situation where we need to deploy tracking systems from multiple different vendors on the various studios and stages that we design and deploy. And so this is a very kind of a passion project for me over the past couple of years, and making sure that if we deploy 5 different systems from 5 different vendors, that we can count on them speaking the same language, essentially. The need for this really, for me personally, started back in 2020, mid-pandemic. I was hired by a company to sort of put together a shootout between the then leading tracking systems. So we had Moses, we had Stipe, we had OptiTrack, we had all these different vendors on a single project, and we were supposed to just compare who were the most precise, who were the most accurate, and we had a number of different metrics that we were supposed to measure. And the biggest challenge that we had was not deploying these systems or calibrating them, or which typically is a bit of a challenge. It was really to compare the data that came out of these different systems, as they were all talking different languages. So that's really where it all started for me, and realizing the need for interoperability and making sure that everybody what actually comes out of these systems can be guaranteed to be the same and be comparable, and also interoperable.
Yes. So what we have up here really quick, if you have your smartphones on you too, is our OSVP wall chart. So this is kind of taking you through what we've been working on at RS as well, looking at the different departments, the different roles, the different way that the path of a virtual production project may take. The hard part about doing a wall chart such as this is that it is ever changing. Roles are used in different scenarios. Data is used in different scenarios, as we well know. And, as it states here, there's lots of protocols, there's different standards, and everybody's implementation, be it at whatever project or company you're at, or individually for your own projects, the workflows and the data paths can vary widely. So what we've been trying to do here is collate all this data, specifically for camera tracking. And, being that a lot of us here have either used, tested, or broken all of, inside out and outside in, tracking solutions and looked at the data paths, we started down these endeavors of looking at, like, how do we rapidly come to, an agreement of collating all this data together, and how do you parse it and then get it into something workable? Anything else before I go to the next slide?
I was just going to add that, because I personally went through this, because we are a vendor in the context of what's written up there, and there was no standard, so we made our own protocol, and of course that's what everybody's doing. So there's a gaping hole there for an organization like SMPTE through Rapid Innovation Solutions to solve that. And that it doesn't just improve interoperability, it also nurtures innovation. It allows for it just makes virtual production easier. And if I had to summarize what my kind of role is at Moses, apart from supervising software teams and things, it's really just to make virtual production easier. And I think this is a really big step in that direction.
Agree. Yeah, go for it.
If I can join in just to talk about the problem. Those of us who have developed our own protocols, they were probably serialized, probably binary. You've got a slot for this piece of data and it's this wide. You've got a slot for the next piece of data and it's this wide. If you wanted to go from 32-bit to 64-bit, you can't use the protocol. If you wanted to add a new bit of metadata, it doesn't fit in the protocol. Now, those of us who were, trying to think ahead may have put a packet ID into our protocol to identify the type of packet. Okay, so now on the server side, you can identify the packet ID and switch your parsing around to understand that it's a different kind of data that's coming in. The problem with all of those proprietary protocols that do that, including, in years past, my company's protocol, were that they were fixed, and there wasn't really the ability to expand. So what we're introducing here with OpenTrackIO is a protocol that can actually be expanded, and you'll see we're going to be talking about JSON in a few moments. New fields can be added to the same protocol without it becoming a different protocol, without it becoming a different packet. So it's inherently useful to everyone for all purposes. That sounds grand. But I see that this is a protocol that is going to be used for the next 30 years simply because it doesn't break, because it isn't going to be bursting at the seams, because JSON is self-descriptive, it's expandable, and the definition of metadata can evolve.
Which brings us into what this initiative is with OpenTrackIO and it going live this morning in being available. So the web page is live. This is actually just a little QR for everyone to grab and look at. There are the data examples and explanations out there for everybody to look at. And the main pain points that we've all kind of been talking about, and I'm sure all of you in the crowd as well are going through, is getting this data, parsing it, and being able to interop it between the different various workflows. Like we said, you've heard everybody, I'm sure, say this week at MTS is there's a lot of varied workflows. There's a lot of solutions out there, both hardware and software side, that need to interop together, and they don't always talk to each other in terms of the data flow. The benefit too within RIS is having the consortium of vendors and contributors is we're able to get a lot of different voices from vendors, from workflow experts, from practitioners day in, day out on set and on location to give the input into what needed to be in component level on OpenTrackIO. And we'll get to the examples as Steve mentioned too, is getting to the question of why we chose JSON instead of some other form in terms of the protocol, and getting to kind of the explanation and the examples of what we're doing here. So question to my fellow panelists is within these workflows with OpenTrackIO, giving the pain points that were coming from, vendor, company, vendor, and, having supervision level, and we're actively on productions is, maybe James, you can start off with the question of, with OpenTrackIO, trying to collate all this tracking data, being that there's so many vendors out there, what are some of the pain points that OpenTrackIO is trying to solve, knowing that there's a lot of things that can plug into this type of metadata from tracking?
Sure, yeah, I'll start and then I'll hand down the line. I guess I do encourage you to visit the full site that was on the QR code in the last slide, or opentrackio.org. We just got a little extract of it here, but that sort of describes in detail the rationale, but also some detail of the actual protocol itself, which we won't go too deep into here.
Sorry.
I just wanted to say, or start the answer to that question by saying that virtual production actually covers quite a wide range of things, and I think the term has been kind of consumed by LED production or in-camera visual effects, but in fact, at MOSIS and many of the vendors and contributors to this have been doing virtual production for like 25 years, because it's really synonymous with real-time visual effects. That's what we're talking about, and of course, That's been possible in, that it covers everything from broadcast virtual studios, AR, in-camera visual effects, yes, but also set extensions to that, so XR, mixed reality applications, and also reaches into previs and those kinds of virtual production applications where you're using real-time graphic engines to generate pre-visualizations, both in pre-production and on-set production. So, yeah, I suppose it's not just about LED, I suppose is what I wanted to make clear. And this is something that covers, we hope that OpenTrackIO is going to reach not just into that very quite specific area of cinematic production, but it's also going to touch a lot of broadcast and even corporate and streaming applications.
Sure. I guess I'll just add, my co-panelists might bristle at this, but it's possible that one of the greatest virtual production tools has not been invented yet. And it's not purely an inside-out tracker or something similar. It's some sort of magic wand that we have on a virtual production stage. I would like to see that device use OpenTrackIO, which is why I got excited about the notion that a protocol, it should be expandable.
Yeah, I'm coming from the broadcast, live broadcast industry, so I'm very aware how much we need that data, especially from the old, at this point, 3D. This is the solution for interoperability right now. And yeah, I think we're going in the right direction. The only step forward is 172110-41.
Yeah, I think, what was the question again? Pain points. Yeah, I mean, that's a never-ending story, really. I think for me, something that I believe OpenTrackIO opens up some new doors is really about the looking at the workflow that happened after you've finished on set, in terms of archiving and ensuring data integrity. That's something that we try to keep in mind a lot. Like, we ensure that first of all, the protocol is human readable. So you can actually look at it pretty much in a text file and see what's going on. There's also built-in metadata for, synchronization, PTP support, et cetera, So essentially every single packet contains a timestamp on when this happened, which will make it a lot easier to actually take the tracking data that was recorded on set and use it in post-production. That has been a major pain point for a lot of us probably, and that's something that I'm really excited about.
And not to be outdone, but OpenLensIO is another initiative side to going through all the calibration between calibrating cameras, tracking systems, and lenses. It's all in the same family. It's a multi-step process that we all have to go through, whether we're doing simulcam or we're doing, just a traditional chroma background for mixed reality, for live or events, or studio, or in-camera visual effects. But James has all the better side of describing OpenLensIO in terms of, these initiatives that we're pushing forward, because tied right into that is, while we're doing our calibration for tracking, we're calibrating lenses at the same time and shading.
Yeah. So I often talk about it as camera tracking is half the problem and the other half is the lens. And the only current open source standard for tracking information is something called 3D. And while it does support the ability to send raw lens encoder values, it doesn't support anything about the actual mathematical modeling of the lens that's on the front of your camera. And it turns out that that's not actually that straightforward a thing to model, especially if it's a compound lens broadcast ENG lens, for example, it's got multiple elements inside. All of those elements of glass, they're analog, they have their own characteristics, they move in tandem, and we need to have a really good virtual model of that inside the computer, and that virtual model has to change every frame. And this is why it tends to fall to the tracking providers to help look after the model of the lens, because the camera tracking system is sending the position of the camera every single video frame. We also need to send the characteristics of the lens every single video frame. But just like with the tracking side of things, everyone has evolved their own models, mathematical models for lenses, and the intention of OpenLensIO is, and this is not for the faint-hearted to hit this QR code link. It's a very lean mathematical white paper that describes the decisions that a lot of tracking manufacturers, again, have independently made about what axes or which way round, what units you use to describe the characteristics of the lens and things like that. So OpenTrackIO uses the OpenLensIO mathematical model, and we're really pushing this out now for feedback from all of you, from lens manufacturers. It's really the core reason we haven't gone to a version 1 is because we need to hear back from a lot more people on the mathematical model before we sign off on this white paper. But it's one of the core pieces of work that the RIS have done during the development of OpenTrackIO, and we're really proud of the results. So if you are a fan of a bit of maths, do check out this link.
Speaking of math and data, and Steve's favorite part too of diving more into this is an example, of the data. And this is a shorter example, but looking at this when we're going through the input from other manufacturers involved and developers and engineers to say, like, what needs to be in this? What identifiers need to be called out? How are we parsing this data, looking at all of it? And Steve, maybe you can pick up, because, your data points on screen now are, why the consensus that we went JSON and put in the type of identifiers that we did within OpenTrackIO.
Sure. Firstly, this was a collaboration between a lot of people who didn't agree at the start, and we put it all together and we compromised and realized that the greater good is what's important in data. I guess I should point out. So I wrote a parser library for this protocol, but it's sample source. It's a reference example, and so we have that in Python and we have that in C++. If you're developing on the server side, and we are working with Epic to put this into LiveLink in the near future. The data that you're looking at, sure, you see some data. You might be wondering, well, where are the units? So I debated for long and hard for a long time that we needed to put units right in here. But what we ended up doing was we decided that was the responsibility of the parsing library. So if your virtual production uses centimeters, you're not going to hate OpenTrackIO, because the parsing library, you can set your preferred units and you'll get, focus distance in centimeters. So there are multiple layers to this, but OpenTrackIO does, if you're wondering what are the translations in, they're in meters. And we've settled on doubles, for high precision. We're dealing with real numbers and rational numbers rationally, so that you don't lose precision. The protocol itself has, I'll just point this out, it has a static block for data that doesn't change, for instance, a lens serial number and so forth. And it has dynamic sections for data that is volatile, that streams in every frame. So we've basically tried to anticipate every usage case, and it helps that there were, Jim, how many vendors do we have on the committee? Is it 20?
I think we're over 20 now, but quite a bit of vendors.
A lot of perspective went into this because everybody approaches virtual production, from a different perspective. So you'll find that's very complete, but again, version 0.9 instead of 1.0, we want public comment as to what people think we may have missed. So, log into the website and please give us those comments.
Yeah, and the other really good thing that we went back and forth to is, if you have one particular cinema or ENG style lens, be it a zoom, be it a prime, be it spherical versus anamorphic, and everybody loves to calibrate anamorphic lenses, I'm sure, it changes hands so many times if it's not specific to that studio. So if you're getting different lens sets from different rental houses from different parts of the globe, even back to the stereo days when we're trying to do match pairs coming off the line from different lens manufacturers, unless you went through and you were doing this on a visual effects supervisor level or data wrangling level, or camera reports, this data, as Steve said earlier, was on the floor. Different things happen to, lenses and systems and cameras as they're coming in and out of productions, the great thing that I could see with OpenTrackIO is being able to have like camera rental houses be able to, put data into the protocol or into metadata of a particular camera as a sidecar file that can go through, and you can say, hey, look it up. This lens was serviced on this date. This is what we did. We had to take out the rear element to X, Y, or Z.
Could I add? So sure, if you're streaming UDP, you've got a whole lot of bandwidth, but it's also possible to use OpenTrackIO in lower bandwidth connections, forms of serial communications as well. The compression we were talking about, we were using CVOR on the slide. You probably saw that for compression. The protocol does not have to be compressed. So it's very flexible in terms of use cases and bandwidth.
Yeah, we provide transport recommendations, but really the work of OpenTrackIO and OpenLensIO is about semantics. It's about the meaning of the data. It's about what the units are, what direction they're pointing in. It's about semantics. And we will be providing more detailed reference implementations of how to actually move it around on the wire. But actually that's sort of the easy bit. The hard bit is agreeing what the data should mean.
Yeah. And speaking of data, something that we put out through our camera and lens subgroup earlier, which was CamDKit, which is has been publicly available for a bit now. Thanks, Pierre, as well for managing a lot of the Git, because other than the four of us up here, there is large swaths of team and other individuals that have been contributing to CamDKit and to OpenTrackIO and OpenLensIO. They either couldn't be here or there's only so many people who can fit up on the panel, and somehow we've got elected to discuss a lot of this. But James, maybe you can tie in how we've integrated CamDKit into the side with OpenLensIO and OpenTrackIO. Sure.
So CamDKit has been in development since really the beginning of RIS. It was the first open source initiative about trying to start to understand and process metadata from cameras, and it made sense to use that as the backbone of OpenTrackIO. So all the OpenTrackIO website that you see is actually generated from CamDKit. And that means when we reversion things, those things automatically update. This is all part of, presenting stuff in the open source to the community of open source developers, so they can continue and even wider than the RIS group, people can start to contribute to the OpenTrackIO project. So Moses have released a full C++ API on our GitHub. We've open sourced that. We hope others will, pick up, for example, an embedded C API. When we have transport recommendations, we hope people will open source reference implementations. So it's really, we are starting this as a full-on open source project. We want vendors to contribute to that and to grow the, from this kind of core basis of CamDKit.
Good to move on. So tying in future editions, adding to, as we get feedback now that OpenTrackIO has gone live this morning, and getting feedback for OpenLensIO, and still wanting more contributions even to CamDKit side, is really championing the community at large. We only know the voices that are contributing within RIS, and it's really important for us, if you're working within these workflows, or you have protocols that you've written respectively, or you have input in terms of getting the data that we've put out there, and you have questions, or you feel that we've missed things. This is a really call to action for us to get your input. So even if you're not currently part of RIS, or have even been to any of our meetings, definitely reach out to us, myself or any of us, the leads on the subgroups or co-chairs, to figure out how you get more involved, because there's quite a bit of traction that's been going on with what we've been working on, and especially how fast recently OpenTrackIO has come to be. As Steve mentioned earlier, there's a lot of conversations that were very deep in Slack as to what things should be, or things that workflow-wise had different input in terms of like, what is the type of data? Are we getting X, Y is Z up, is Y up? What which parser is reading what in what way? Definitely took some Slack threads to get through in that way too. But James, if you want to tie in, or Steve, on the future editions, feel free to add to.
I think I'll just comment on the fact that open source is key to this. All of OpenTrackIO is going to be open sourced, and the Academy Software Foundation is going to be involved. Just because we have 20 plus vendors collaborating doesn't mean that we're necessarily the experts. An open source project can be picked up by other people in the future. So this isn't just a top-down, we're the authorities. This is really a pretty flat collaboration of, these are all of our ideas, and there certainly can be more ideas brought into the project because it's open source, and it will continue on in the future.
James?
Yeah, I think that's absolutely right. This is the beginning of something, and we hope, obviously we want adoption. Adoption really helps. So, and we're really pleased that Epic are going to be implementing this in Live Link, and that will hopefully encourage adoption from producers of this data type as well. So yeah, it's the beginning, and it's very exciting. Yeah.
Yeah, just an addition there to the adoption side. I feel like, yes, we've gained surprising amount of traction so far. Like, as I mentioned, Epic, Moses, Stage Precision have all been committing resources and committing to implementing the protocol. But I think the key here is really that the power in making sure that OpenTrackIO really gains traction and widespread adoption is on the consumer side. And I'm not meaning consumers as in people who go out and buy iPhones, but the people who actually need this data, we're the ones who need to ask our vendors to implement this, because that's really the only way that it's going to get out there. And we want to all step away from having the proprietary madness that we currently have. So if you're in a position where you're working with various tracking systems, from various vendors, ask them to implement OpenTrackIO, and ask them to contribute. If they feel like the OpenTrackIO in its current iteration is not exactly what they need, then the door is open for them to contribute and help take this to V1.
Do we have time for questions before we finish? So we're going to jump into questions really quick. Big thank you to fellow panelists and all of our other contributing RIS members for helping get an OpenTrackIO to its current iteration. And then, obviously we implore all of you to get involved with us.
So we'll take two
questions.
Currently, where are you guys at as far as accuracy between cameras in regards to pixel? How close are you as far as accuracy goes to knowing where these cameras are in space?
It really depends on your tracking system, but certainly from our perspective, visual effects artists have told me that they are getting better accuracy from on-set camera tracking systems than they can get through match move. And obviously you don't need the markers in the scene and all that kind of stuff. So we call it at MOSIS, we call it near pixel accuracy. So, it's close to the pixel. We have 1 millimeter and 1/100th of a degree on the camera. It's harder to measure it on the lens, but this is really, really important usable data for, downstream visual effects. And it's not just about camera tracking as well. It's about driving robotics. And you need different accuracies of camera tracking for different virtual production applications as well. So, yeah.
No, please, yeah. Okay. Now, I was just going to say as well that, thank you, James, by the way. I think OpenTrackIO, obviously, the level of accuracy that you can get to with the data or the data types that we've introduced is, sub-micrometer probably if you really want to get that close. But one important thing that OpenTrackIO doesn't do is that it doesn't impose any restrictions on how you as a tracking system vendor get to that accuracy that you need. We don't impose any specific calibration routines or specific calibration methods. That's still up to you as a tracking system vendor or as an engine manufacturer to establish the best practices for your customers. And OpenTrackIO will just make sure that the data gets from point A to point B, C, D, etc. in the most efficient and accurate way possible.
One over there. Yeah. Question?
Hello. Again, amazing panel, and it was pretty interesting. I think a lot of us are going to do a lot of reading out of this. And I just wanted to ask, you've talked about interoperability of OpenTrackIO. I am of the belief that sometimes these smaller productions, more indie productions that really push technology to its limits. So I just wanted to ask if you could speak to what OpenTrackIO can sort of bring to maybe smaller productions and how these can potentially maybe even push it further and apply it in maybe different ways that haven't been thought about and stuff like that.
It's a good question. So if you didn't hear, it was smaller productions.
Yeah,
getting involved with it.
As Marcus said, the protocol itself does not prescribe the tracking system or the quality of that system that you use or the price you paid for it or anything like that. So it's really designed to be, for all levels of production and virtual production. There is no sort of inherent limit in OpenTrackIO that says you can't use an iPhone to track this or a VR headset or whatever else. So yeah, I don't know if anyone else wants to pick up on that.
Well, I'll just say about small productions or even student productions. So, if you're on a limited budget or if you're just wanting to roll your own technology, encourage your coworkers not to design their own protocol. Go to opentrackio.org. And if you're creating that new magic wand, have it stream with a standard protocol. It's going to go into the various 3D engines.
I fully expect someone to create an iPhone app that generates OpenTrackIO data, and then you can slap an iPhone on your camera and track that way. I would really like to see that, and that's kind of what I was saying earlier about fostering innovation. It's not just about interoperability.
Yeah. No, and I also think that given the open source nature of OpenTrackIO and the fact that the RIS OSVP group, not only the 5 of us, have done a lot of the heavy lifting that is actually involved in developing this kind of protocol, it kind of opens the door for, I guess, lower costs or lower R&D costs on the manufacturer side. You no longer have to spend R&D resources on figuring out your own tracking protocol, which could potentially open up the door for lower cost tracking systems out there suitable for indie and then smaller productions.
Yeah. Last comment is we have data wranglers right now, but this is going to open the door to a new generation of data wranglers. And what I'm talking about is record all the metadata into one box. That's going to happen. There's going to be new companies making metadata recording. Right now, every studio do their own data wrangler, and they record on text files or spreadsheets. But I think this is going to start a new part of digital production and broadcast in general, which is data wrangler for all the metadata. And it's good that we started.
Yes. So read up on it and and come ask us questions. But thank you. Thank you, everyone.
Yeah. Thank you to each one of our panelists today. And please keep the applause going for all of our presentations.